Welcome, good people. My name is Joel Collier, and today we're going to talk about how to present your structural equation modeling results in your journal articles. So, one of the questions I get a lot is, I understand how to run the analysis and I got my results now, but I really don't have a good idea of like how to present those in my paper. Like, do I put all of it in the text? Do I just dump all of it in a table? And how does it look in the table? And it's just a common question that I get a lot on, what's just really the best practice to present it to the reader where it's not so burdensome for them. The one thing that I will say that gets kind of reviewers really sideways with you too is what I call kind of lazy reporting of results. And the most common thing that I see with that is somebody will take, like, for instance, an Amos model with its results, which would look like just like this. Um, and they'll just cut and paste it right into their paper and call it like figure one. Like, reviewers hate that. For one, it just shows a lot of laziness on your part to go not to come back and put it in a nice looking table. And two, it's oftentimes very difficult to see, the specifics on this particular kind of printout. It's not meant for that. It was really meant for the user to kind of see it from a preliminary standpoint. It's not final finished form by any means. So, saying that, don't do that because reviewers, for the most part, dislike that. It shows kind of laziness, and really, there's a better way to do it than just kind of cutting and pasting actual kind of screenshots of your sim. So the first one I want to talk about is confirmatory factor analysis. So with a CFA, you may have, let's say, 50 items in your survey and multiple constructs. Do I want to talk about all 50 items, in my paper? Well, you need to report the results of all 50 items, but do you need to talk about them in the text? No, because it will really drag if you do that. The reader's going to get bogged down in the details. So, kind of best practices, what I encourage is in the text when you're writing it up in your paragraph form text, provide an overview of the model fit of the CFA. Note if all the loadings were actually significant. If it's not, you may have to note that a little separately. All but one construct's loadings were significant. I also like to put reliabilities and talk about it right here because you're really talking about measurement issues at this point too. And so this is really a good spot to talk about reliabilities. Um, I'll also say you probably need a table if you have a CFA because a lot of people want to see the specific loadings for each one of your items, but they don't want you to talk about it in the text. So you really need a table. So that's where all your kind of specific loadings will go. T-values of those loadings. I would put model fit statistics back in again right there, and reliabilities. Some people also like to put where they get their scales from, if they adapted it from somewhere, which is a really good place to put those. So let's give you an example here. So this is a screenshot from one of my published papers. Again, just kind of a template if you needed to follow to be like, what do I need to say really? So in this right up here, you can see where I say a confirmatory factor analysis is performed for each sample to assess unidimensionality of measurement items. In this particular paper, I had two different groups we were sampling. It was about experience marking. One was at concerts and one was at like weekend vacations. So we had two of those kind of confirmatory factor analysis we did for each one of those locations and samples. So initially I'm just saying like, hey, why did you even do this? Well, it's to assess unidimensionality of our measurement items. The results of the CFA analysis indicate each item loaded on its respective underlying concept and all loadings were significant. All right, so again, I'm not talking about individual ones. Hey, they were all significant, they all loaded on their appropriate construct. Moving on. Construct reliabilities were also assessed for every construct across both groups. Now here's kind of the key. Because right after that, they're going to be like, well, I want to see the specifics. To view the complete list of items, loadings, reliabilities, see Table 3. And then I'll give you an example of what, that table should look like. Right? And if people want more than just that, some reviewers really want to get into the nuts and bolts of the discriminant validity and convergent validity of your CFA. You can give them for the means, correlations, and average variance extracted for each group. See Table 4. So you can put up a separate table and put that information in there without bogging down the text. And then lastly, the model fit indices also suggest that the measurement model was a good fit to the data. And so in here, what I usually do is I report chi-square, degrees of freedom, and then I'll usually put 3 fit indices in there too. 2 goodness of fit indices, so which is comparative fit index, and then Tucker-Lewis index. Those are considered goodness of fit indices, like how good did it fit. And then I'll also report root mean square error of approximation, which is typically what we call kind of a badness of fit indice. And so it kind of gives you a different perspective. But that's really all you kind of need to say, from a write-up perspective, right? Here's what it was. Here's why I'm doing it. What was the loadings? Did they load? Where can I find the specifics? What was the model fit as a whole? Let's move on to the other stuff. Now, in the table, here's an example of what the table would look like. Is it the only way you can do a table? No, but I just feel like it's a good way to actually present everything in a very clean manner. What I like to do at the very top is I'll put my actual constructs, and I'll bold those out. And then underneath it, I put the actual survey items or scale measurement items that I actually use. So for instance, this construct is perceived adaptive behavior. I'm not going to put adapt 1, adapt 2, adapt 3, adapt 4 down there, because that doesn't tell me anything as the reader if one of them is really poor. Like, I want to see the actual items that you use, because then I can understand, like, well, I understand why that item was poor. It's really not, asking about this specific construct. That's really something else. So put the specific items in there, what you actually used in your survey. I also like to put composite reliabilities. Sometimes you'll see those kind of put in kind of parentheses right after the construct that's out there. I always want to present standardized factor loadings in my CFA. There's really no reason to present unstandardized factor loadings in a confirmatory factor analysis, because you're trying to show comparison across all of your measures and in regards to its validity too. So you really want to present standardized factor loadings. Also put the t-values in there. Notice in the t-values that each one of these constructs have what I have in here is just stars. Well, with a CFA within each construct, one of the items itself has to be constrained to 1. It's called setting the metric. Kind of tells the software program what's the range, if you will. So I don't put just 1 in here, because sometimes if your t-values are really close to 1 too, in this instance these t-values are huge, but if your t-values were like 1, 2, 2, 1, well, it can be kind of confusing, just to have it as a 1 and may blend in there and they not realize, well, that was actually the constrained item. So I just put those as stars in the t-values, and then down at the bottom I'll note, hey, these stars mean that this item was constrained for identification purposes. So I do this for all of the constructs. And then at the bottom, I'm going to put the model fit indices again. Like, well, why put it again? You just put it in the text. Yeah, but if I'm at the table and I'm the reader, like, I want to see everything in a really kind of one-shot kind of deal, which means I may not have remembered, from that model fit indice what those specifics were, but now I can go back and look at it and be like, oh, even degrees of freedom was 41. Wow, that seems kind of low for as many constructs as we have here and measurement items. So, again, it lets the reader have a little bit more information. If you use acronyms for anything in your table, make sure that you actually put those down as a note at the bottom, too. Well, for instance, this was composite reliability, but I had noted, like, if you don't know what CR is, here's what that acronym actually means. So here's one example of this. Another example would be very similar, except some people really like to see, tell me where you actually got these scales from. If you adapted them from someone, put the citation right here where it was adapted from, right by the actual constructs. And to still have the reliabilities in here, they kind of move that over into the standardized factor loading, but just put it into kind of parentheses with that CR again. But it's kind of straight across, if you will, from the actual construct name itself, not a measurement item. but very similar to how we just did it, except if you just want to put more information in there about like where these came from, here's an example of how to do this too. The other thing that you're going to see with reporting of results is really from a structural results perspective. Most common ones you're going to see with SIM are CFA and then your structural model results. So in the text with the structural model results, you're going to present the overview of the model fit again. But really, you have to talk about every hypothesis in detail. So you can't be like, all the hypotheses were significant, go see the table. So this is not kind of a confirmatory factor analysis. This is structural model results. And you spend a lot of time in the conceptual development and building up this hypothesis, and you can't just be like, go find the results in the table. You really need to talk about them in the text. Now, saying that, if you have more than like 4 or 5 hypotheses, you probably need a table too, because they're going to get a very blended in what the kind of results are too. And so usually I try to put a table in there to make it very clean on exactly what all the results were. Now in that table, I'm going to have regression coefficients, I'll have t-values, I have model fit statistics in there, so they can specifically kind of see everything. So here's an example of what that would look like. This particular one didn't have that many hypotheses, but it's a good kind of template for you to kind of see. Now this example here was actually doing a 2-group analysis. We were looking at customers of a restaurant, and we were just seeing if there was a difference between them, between those that had never been to the restaurant before, were first-time customers, and those that were repeat customers. So we're doing kind of a 2-group analysis here. Now if I just had one group analysis, then I could probably just have just that column that says like first-time customers right there, and I really don't need anything else. But if you're trying to do multiple groups, then here's kind of a template too to kind of show you what it would look like out there. Now the first thing I want to do is I always want to put in kind of what is my hypothesis number. Give the reader may have had that like 7 pages ago when they were reading. So go back and be like, this is hypothesis 1. And what I like to do when you're talking about structural results is I'll put the constructs, and I don't put like adaptive behavior to delight. I actually put this symbol of the little arrow here. So it's almost, very similar to my model, how I've drawn it out. But it's easier for the reader to kind of see exactly the relationship you're talking about. Oh, adaptive behavior to customer delight, H1. I'm going to present those standardized regression coefficients again with this. I like to put the t-values right beside it, in parentheses, and I'll note down here too, usually if there's a level that is going to be at a specific significance level, if it's like a 0.05, a 0.01. In this instance, I'm putting the specific t-values in here, but if you had you're cramped for space and you just wanted to put like stars, some people do stars for like a 0.05 or 2 stars for a 0.01. But they have to note that down there in the notes at the bottom of the table. But I put the specific t-values in here because it lets me tell, like, well, how close to significance was it? Was it barely like 1.99, significant, or was it, way past that? So I like to put specifics in there. And the other thing too, in this particular instance, was we had 2 groups, and I actually wanted to see if there was a difference between these 2 groups. So we ran them individually, but now we wanted to see, are they significantly different from one another? What you can do is you can put another column out here and just do kind of group differences as well. And the reason we did this through a chi-square difference test. So I'm just putting a new column out here, and so I'll just do the change in chi-square divided by 1 degree of freedom. So what was that one degree of freedom difference between the two? All right, and so I note in here, so it's significant at 3.84, but you can't just let the reader be like, well, you should know that, right? 1 degree of difference of chi-square is 3.84 at a 0.05 level. Well, they're not going to remember that, so you're going to have to note in there, and usually kind of what I do is I use those kind of stars, right? So stars are saying that, hey, this was actually significant at a 0.001 level out there. So Again, and I'm going to put my model fit just like I did the CFA, chi-square, degrees of freedom, two goodness of fit indices, and then one badness of fit indice in there. I've got a shot to see like everything in one table at this point, especially if I have a lot of hypotheses. It's easy for me to go back and see each specific one. The way that I've presented it with the arrows makes it easy for me to see what the relationships are. And then now I also see kind of standardized regression coefficients, if it was significant, and other information that I need. The other thing that you will see too is mediation results and how to present those. So initially, for instance, in this model like this with x going through m to y, in our structural results, we would probably present this a path, or x to m, and the m path, to y, which is the b path. So that may actually get presented in kind of the structural results. But the indirect effect is really something different. And to assess indirect effects, we most likely will be doing a bootstrap to assess the indirect effect. I've got a whole other video on this if you're interested on how to assess indirect effects. But this is really just focusing on how to kind of present those results. So with this, it's going to follow a little bit of a similar format as the structural results, except this time I like to put in the table here. Hey, this is a test for mediation. I used bootstrap, and I also letting them know exactly what my confidence interval was. This is 90%. Sometimes people do it at a 90% confidence interval. Well, I put this at specifically a 95% confidence interval. I like to have these relationships kind of like I did with the structural relationship with the arrows included, that symbol, because it lets me tell exactly what the indirect effect I'm testing. In this particular instance, it was adaptive behavior through a construct called customer delight to really positive word of mouth. So I wanted to see what's the indirect effect of adaptive behavior to positive word of mouth through that delight construct. So initially, I'm going to present the direct effect, which was what was the direct effect of adaptive behavior directly to that positive word of mouth. Right, so the direct effect is in here, and then also in parentheses, I'm going to give you the t-value, which that t-value says in this one, it was non-significant. Then I'm going to present the indirect effect, right here, and beside it, I'm going to present the confidence interval of the high and low. That's going to tell me if my indirect effect was actually significant or not. If that indirect effect within that confidence interval crossed over 0, or if it didn't. Because if it doesn't cross over 0, it's at a significant level. I like to put the p-value in here as well, just to kind of give the reader a little more information on its significance level. And then lastly, with the indirect effects, because you can come to different conclusions, I like to put what the conclusion was. Was it full mediation? Was it just partial mediation? No mediation, whatsoever. Just to make it easy on the reader. Down in the notes, I will note down here, like with the mediation, that I use unstandardized coefficients, and that's because of the bootstrap. So just to kind of let them know as the reader, like these are not standardized, coefficients are unstandardized because of the bootstrapping. Values in parentheses are t-values, and then I also let them know what my bootstrap sample was. In this particular instance, it was 5,000 samples with replacement. This second one down here it was a large model. We actually did 2 tests of indirect effects. And so here's just a separate one. Instead of adapt going through delight to positive word of mouth, this one was adapt going through delight to another dependent variable. And, providing direct effects, indirect effects, confidence intervals, was it significant? And then what was the conclusion that came from that? Again, just a way to kind of give you a template of how to kind of present these in your paper, your journal articles right here. Now, there's a lot more information on how to present your results, especially when it comes to moderation. Now, moderation can be a little difficult because you've got different ways to assess moderation, from interaction terms to actual categorical moderators. And it gets even more complicated when you're talking about moderated mediation, which has kind of the values of index of moderated mediation, which determines if the moderator is actually moderating the complete indirect effect. So if you're looking for more information about how to present results of moderation too, I'd encourage you to check out my book. I can't put it all in this video, or this video to be like an hour long, because it does get a little complicated when you're talking about probing interactions, highs and lows, and what's the best way to kind of present those. Also, if you're looking for other information and more advanced techniques on how to present those, like latent growth curve models, the book does a really good job of kind of explaining just how to present it more than anything else. And I'll put the link down in the description too on how to get that book. Lastly, is this the only way to present, your results? No, absolutely not. But it's a template that has worked well for me in the past, simply because it's a way for the reader to see all the information in a very easy to understand manner. Um, and so you're still telling a story, but at the same time, you're not letting the story get bogged down in the results. Sometimes you just need to put it in the tables and let them get into the specificity in the table, but not necessarily in the write-up. But at the same time, you don't want to just, kill them with content in a table to the point it's really hard to make heads or tails of what that table even says. So if you're looking for more information, again, I'd encourage you to check out the book. And as always, if you saw value in this video, I'd ask that you like and subscribe for more videos to come. I hope y'all have a great week, good people.